And we are back. So today's topic is going to be about loops, very important concept, so please pay attention. Spaces and tabs have special meanings in Python, especially if they are to be the left of the statement. Some rules to guide you: don't use space to the leftmost part of the statement. Use tab instead only if the following keyword has been encountered in the line. I'm going to highlight this for your benefit. Right, this is very important. Except for this, you do not use the space, because if there is an error, like if you remember in one of the previous lectures, there was a small space because of which the program was not getting executed. So similarly for for Python also, it is very crucial that you ensure where you need to apply a space and where you don't need to. So use tab instead only if the following keywords has been encountered in the line before: if, for, while, def for definition, class, try, except. Finally, other such keywords will be dealt with later. But for now, if one of the above keywords has been used, then all subsequent lines that are supposed to belong to the statement scope are shifted from the left by an extra tab. This feature is called indentation, and it is necessary for Python to understand which block of code belongs as one unit and to which statement. Please pay attention, important, crucial, because this is something that you may have to use on a day-to-day basis. A equals to 3 in cell 2. This program will run as it has tab from left at appropriate space. Hashtag commented out will not run. If A equals to 4, print A is 4. So there is a difference between a single equals to and a double equals to. We will see. Very important. This program will not run as it does not have tab from left at appropriate place. Look at the error. It says indentation error. Right? So whenever it has to be a print, it has to be with a tab. Has to be with a tab. So very crucial, very important. This bit. Right? So Python is actually telling you where is the error. Right? Tab means that from then on until the tab is back, it is considered as one block of instruction. So we are going to see the example below. For I in range 5, square number equals to I asterisk 2. So of course we are talking about a square number and a cube number. This we had seen at the very initial stages of our lecture. 1/10 of a number is equals to I divided by 10.00. Print, this is a first block, square number, cube number, 1/10 number. If I is divisible by 2, which is equals to 0, print, this is second block. Print, this is the end of this block. Else, print, this is the third block. I is not divisible by 2. Now we are going to do a very interesting exercise whereby we are going to use if and else statement to understand and derive at a situation or at a logical ending of a situation. So if any of you are engineering students or any of you are interested in data science, there is something called as decision tree in data science. So we are going to see a similar example in Python, but by writing a code. Very nice. My students just really love that. So we are going to come to that. Conditionals and logic. We different decisions in life daily depending upon what is the answer to certain questions. So these are kind of examples. You don't have to go through them, just an example. So if I will come today, I will come to college, else I will not. So this is an example. If Koel ma'am, which is me, will support me in learning programming, I'll do my parents proud in programming course, else I'll focus on maths. If I ask programming questions and I don't know that, I will slide under the desk so that she does not see me. So these are some funny statements that I have given so that you understand what I'm coming to, because you know, programming can be really fun when you try to put different permutations and combinations. You can see above, your next answer is dependent upon yes or no answer for some questions. There is no end to it as to how many pre-questions you can ask before you take a decision or execute a task. Now when we were kids, we used to have a flow chart. If this happens, yes, no. If that happens, if yes, then yes, no. If no, then yes, no. So on and so forth. Same like a decision tree, but much more precise and to the point. If a is greater than equal to 5, I will print hello, else I will print y. How will we write this statement in Python? A equals to 5. If a is greater than equals to 5, print hello, else print y. So first I have defined what is the value of a, which is 5. Then I'm giving conditions, and then I'm passing those conditions to get an answer. If a is equals to 10, I will print you score 10 out of 10, else I will print you could not score a perfect 10. How will we write this statement in Python? So first I have to define a equals to 10. If a equals to 10, print you score 10 out of 10, else you could not score a perfect 10. So similarly, different examples, different way of printing our if and else statement. If the year is divisible by 4 or it is divisible by 20, I will print this is leap year, else I will print this is unusual year. So this is an example for you. As I have always been doing, I give you a lot many examples for you to get your fundamentals very clear in your mind as to why are we doing this. And this is a very good way of practicing, because that way you understand the whole concept very easily. Like you are focusing on one concept again and again till you get it right. So how can we write such code error free? What is the logic? Let us find and understand the equality test operators. When you compare A to B, there can be 6 outcomes. I told you this in one of the previous lectures, that there are 6 operators. A equals to B, this means we are testing if A is equals to B. Please note there are 2 equals to sign and not 1. So here I am saying, one moment. So here I am saying there are 2 equals to sign without space, right? So I am trying to see if what the value that I have on my left hand side of the operator is equals to the right hand side of the operator. But if I would have given A equals to 3, that means I am storing 3 in A, which I am not doing in this case. Here I am trying to understand if my left hand side of the operator and the right hand side of the operator matches. Similarly, in the next one, what I am doing is A not equals to B. This exclamation sign is for not. Please remember, very crucial. This means we are testing if A is not equals to B. Please note that the exclamation sign before equals to sign, this is a shorthand notation for the word not. A greater than B, this means we are testing if A is greater than B. A greater than equals to B, this means we are testing if A is greater than or equal to B. Please note that the equals to sign is after the greater sign. Right? So you first use the greater or the lesser sign and then the equals to sign. And then comes A less than B. Then comes A less than or equals to B. So 6 operators, do not forget. I iterating again and again. Please do not forget this. So A equals to B, A not equals to B, A greater than B, A greater than equals to B, A less than B, A less than or equals to B. So those are the 6 operators. Please rehash, please reiterate this in your mind again and again so that you're absolutely thorough. We stop here.